Hello students, this is our lecture number 3 on indefinite integral. Today I came with some important problems for your board exam and for your entrance exams also. So without any delay, let us start the video and we continue the previous video. Now we are going to the next question, number 49. So we start with the problem number 49. The problem is I is equal to, this is one important problem actually, I is equal to, it is 1 by square root of ax plus b, then plus square root of ax plus c. So in these types of problem, if you have the coefficients of x in both of these sides are same, then process of integration in all of these types of problem is exactly same. Just you have to multiply the conjugate of this third expression, and the conjugate is just minus. You have to take just minus here, so that is given in the numerator and in the denominator also. So I am writing in the denominator, in the numerator, ax plus b, then minus root over of ax plus c, and this factor should also be multiplied at the denominator. So this is root over ax plus b, then plus root over ax plus c. It is already in the denominator, and I am multiplying by the conjugate, and that was root over ax plus b, then minus root over ax plus c, and dx is already there. So this is equal to, in the numerator the term remaining same, that is root over ax plus b, then minus root over ax plus c, and the denominator is of the form a square minus b square form, and so I can write simply ax plus b, then minus ax minus plus c, ax plus c, ax plus c, and dx is here. So after opening this bracket, this ax and ax will get cancelled. So term b minus c is remaining here. So that b minus c is a constant. So I can take that outside the integral. This is equal to 1 by b minus c is taken outside. And you see the expression now. Now it is integration of this term and integration of this term. So I am taking integration of, the first one is ax plus b. So it is now ax plus b whole to the power half, because square root is actually whole to the power half, then minus integration of the second term is ax plus c, and this is also whole power half, dx is already there, and closing the bracket, is equal to 1 by b minus c. And in the process of integration, if you have some coefficient with x, then always give 1 by that coefficient. Now this term can be considered as x to the power half, and x to the power half integral is obviously this one, to the power half plus 1 will be equal to 3 by 2 divided by 3 by 2, then minus, here the coefficient is also a, so I take 1 by a, and then this term is ax plus c whole to the power 3 by 2 and divided by 3 by 2. Integration is completed, so the constant of integration c is given. So this is equal to 1 by, you see a is common here, 1 by a is common, as well as 3 by 2, that is you can take 2 by 3a as common, and 1 by b minus c is already there. The term is now ax plus b whole power 3 by 2, then minus ax plus c whole power 3 by 2, and plus the constant of integration c, and this completes your solution. And you can solve same question number 48, you can solve yourself. So just write the question and take as homework. So integration of it is 1 by simply square root of x plus a, this is x plus a, and plus square root of x plus b, and dx is already there. So here you keep in mind that coefficient of x is absent here. So in the process of integration, you do not take this one by this term, and everything will be same with the previous question. Okay, so let me take one more question, and this question is important question, number 50, problem number 50. So the problem is I is equal to integration of, this is sine to the power 8x minus cos to the power 8x, cos to the power 8x divided by 1 minus sine square x into cos square x dx. This problem is also included in your NCERT book. So the numerator can be think as, you see, this is sine to the power 4 whole square, and this is cos to the power 4 whole square. So I can write, say, sine power 4x whole square, then minus cos power 4x whole square. Sorry, cos power 4x whole square, and whole terms divided by the denominator, this one can be replaced by sine square x plus cos square x. This is the replacement for 1, and I can give square also, because 1 square is again 1 equal to 1, and you see there is a 2, there is a 2, so then minus 2 into sine square x into cos square x dx. Okay, so this is equal to, in the numerator you see it is a square minus b square form. So I write, this is sine power 4x plus cos power 4x, this is a plus b, into sine power 4x minus cos power 4x, this is a minus b, and see the denominator. Is it not of the form a plus b whole square minus twice ab, and that is equal to a square plus b square. So a square is sine square x whole square, this is a square, plus b square is, b square is, b is cos square x and then whole square dx. Now you see this term can again be expanded by taking sine square whole square and sine cos square whole square. By taking that, you can expand the next one also. So this is equal to, in the numerator, the first one is sine power x 4x plus cos power 4x is already there, and the second part, by the same concept, you can write sine square x plus cos square x into, this is sine square x minus cos square x only, and the denominator is, you see, this is sine power 4x plus cos power 4x. So I write, this is sine power 4x plus cos power 4x, and dx is here. Okay, so after this you see, is equal to, this term is cancelled out, this term is cancelled out, so, and this term is 1 only, this is 1, so your term is now remaining sine square x minus cos square x and whole dx. This is remaining now, and that is equal to, if you take minus common, it is of the form cos square x minus sine square x, and all of you know this formula. This is actually formula for cos 2x dx, and the integration of cos 2x minus is already there. This is simply sine 2x divided by 2 and plus constant of integration c, and that will be your answer. So take the next question, number 51 is very important question. number 51. This problem is also included in your NCERT book. So it is 1 by cos x minus a, this cos x minus a into cos of x minus b. So again, all of these problems can be done by a common method. Just you see here, this term is cos and cos. So you are to write in the numerator. If these both of these are cos, then you have to write sine here. Sine, then see the process. It is a minus, sorry, not a, it is x minus a, then minus x minus b. You write this in the numerator divided by cos of x minus a into cos of x minus b dx already there, integration was already there. Now you see here, after opening the bracket, this x is cancelled, so your term is b minus a, sine b minus a. So for adjustment, you just write 1 by sine b minus a here, sine b minus a. So keep in mind that if both of these are cos, then you should write sine here. Both of these are sine, then also you write sine here. But if it is sine and cos, then you should write cos here. And the process is same in those problems also. And after this is equal to 1 by sine b minus a, 1 by sine b minus a is there, into integration of, this can be considered as sine of a minus b now. The formula for sine a minus b is sine x minus a into cos of x minus b, then minus cos x minus a into sine of x minus b, and the denominator is remaining exactly same, that is cos of x minus a into cos of x minus b, and dx is here. After that you just write 1 by sine b minus e is already here, sine b minus a is already here, you give a curly bracket here, and see, if you separate this integral, this term divided by this term, now you see this cos is cancelled, so your term will be sine x minus a divided by cos x minus a, and that will give us 10x minus a. So it is integration of 10 x minus a, dx is already there, then minus is here, integration, you see again, this term complete this term divided by this term, so cos x minus a will be cancelled out, so your term is sin x minus b divided by cos x minus b, and that is 10x minus b. This is tangent of x minus b, and dx is there. Now this is equal to 1 by sine of b minus a whole into integration of 10 function is log of sec x minus a. This is the formula for integration 10, and minus again here it is log of sec of x minus b, and integration is completed, so you can give the constant of integration plus c is equal to 1 by sine b minus a is already there, and you can combine these two logarithms as like modulus of sec of x minus a divided by sec of x minus b. So you may leave the answer here, and that is your solution. And you can solve one more question of the same type. You write the problem number 53. It is homework for you. So the problem is I is equal to integration, simple, it is 1 by just given cos of x plus a into cos of x plus b. So exactly same with the previous problem, you can solve this problem yourself. So now I am taking the problem number 52. The problem number 52 is given as I is equal to integration of sin x divided by 1 plus sine x dx. So this is your problem. The problem is done in very simple way. Since the denominator is 1 plus sine x, so I can write 1 plus sine x such that the denominator can be cancelled. But it is only sine x, but I am writing 1 plus sine x. So for adjustment, you give a minus 1 here, and denominator is 1 plus sine x is already there, dx. So after this, you separate the integral, it is equal to integration of this term divided by this term will be cancelled out, so only dx will be there, minus integration 1 by 1 plus sine x is there. Now recall, this problem is already done in the previous classes. So this is equal to integrations. First time I am writing dx is same, is then minus integration. How to solve this problem? Just take 1 minus sine x as the product in the numerator and denominator. So it is 1 plus sine x is already there, into I am taking the new factor 1 minus sine x here. And after this, you see, is equal to, the first term is only dx, so integration of dx minus integration dx is this one, then minus numerator is 1 minus sine x, so integration of 1 minus sine x is in the numerator, divided by, in the denominator you see this is a square minus b square, so I can write 1 minus sine square x and dx. So this is equal to integration of dx remaining same, minus integration 1 minus sine x divided by, it is cos square x, and then dx is already there, is equal to integration dx is there, minus 1 by cos square, so you can write secant square x dx, then minus and minus makes it plus, this minus and this minus is plus, integration, the sine by cos square is sine by cos into cos, so sine by cos is 10 and 1 by cos is sec, so you can write this is sec x into 10x then dx. And so now integral of dx is x minus integration of sec square is 10x plus integration sec x, 10x is sec x, and plus constant of integration c, and this completes your solution. So we start with a new question, problem number 54. So come to the problem number 54, and this is very important problem, so you should practice this problem. The problem is I is equal to integration of cos of 8x plus 1 divided by tan 2x, just a minute, tan 2x plus, not plus, tan 2x minus cot 2x dx. This is your problem. So in the solution of this problem, you see this is a formula, so I can write what is the formula. You see the formula first. The formula is 1 plus cos 2x. Just you recall this, 1 plus cos 2x is equal to 2 times of cos square x, and 1 minus cos 2x, this is equal to 2 times of sine square x. You know this one. And in this problem, the term is given as 1 plus cos 8x. And 1 plus cos 8x can be written as 1 plus cos of 2 times of 4x, is not it? And that is equal to 1 plus, sorry, this is nothing but, this is nothing but 2 times of cos square 4x, this 4x. Okay, so I am using this formula in this problem. You see this. So this numerator is 2 times of cos square 4x, and the denominator tan 2x, that is sine of 2x divided by cos of 2x, and minus this is cos of 2x divided by sine 2x dx. Simply take LCM here. So numerator is the term 2 cos square x, sorry, cos square 4x, cos square 4x. And after taking LCM, this and this will be multiplied, and that is sine square 2x minus this and this will be multiplied, and that is cos square 2x. LCM is cos x, cos 2x into sin 2x, and that will go to the numerator again. This is cos 2x into sin 2x, and the dx is already there. So after this, you see the numerator integration of the numerator is cos square 4x, and this 2 can be considered with these two factors. So here it is cos square 4x remaining. So I write here cos square 4x, and then 2 times of, you see, sin 2x and cos 2x, 2 times of sin 2x and then cos 2x, and the new denominator, it is minus can be taken common here, so I am taking minus common, so it will be now cos square 2x minus sin square 2x, and dx is already there. This is equal to minus coming outside of the integral integration. This is cos square 4x, and what about this? This is cos 2x, is not it? 2 into 2x, so it will be cos of 4x. Sorry, I'm really very sorry. This is sine 4x, actually sine of 4x, because you have a formula sine 2x, this is equal to 2 times of sin x into cos x. This formula is using here, and minus is already taken outside, and this is cos 2x formula, so I should write cos of 4x, and dx is there, dx. So minus this cos 4x is cancelled, so your term is now numerator is sin 4x into cos 4x. This term is now remaining because this and this whole square is cancelled out. So after this, you see, if I take half here, I am taking a half here and 2 here, then is it not equal to minus half is already there? Then this term is again sine of. So let me go to the solution for the problem. You know this one. The slope of a curve is always represented by dy dx. You know that one. So dy dx is given as 2x minus 3 by x cube x square. So 2x minus 3 by x square. This is the curve given. And gradient of the curve is given. So first of all, you find the curve, and that can be done by taking dy is equal to, sorry, yes, dy is equal to, this dx can be taken here. It will be your twice x minus 3 by x square and whole dx. Okay. So now if I take integration, so it will be dy in the left hand side is equal to integration of, this is 2x minus 3 by x square dx, and plus constant of integration you may give after finding the integral, and this is implying that y is equal to integration of 2 is remaining here, 2 is remaining here, x integration is x square by 2, then minus 3 is remaining here, then 1 by x integration is 1 by x square integration is minus 1 by x, and plus constant c. So this is implies y is equal to 2 is cancelled, so it is x square minus minus makes it plus 3 by x, and plus constant of integration c. So you mark it by 1, and as given in the question that the curve is passing through the point 1 1, so that means I can use that condition here. So just you write, since the curve is passing through 1 1, just write, since the curve since the curve is passing through 1 1, the point 1 1, therefore you just use x is 1, y is 1 in this equation. So 1 is equal to 1 plus 3. Just I'm writing here, 1 is equal to 1 plus 3 and plus c, I think, yes, plus c. So plus c, and from here you will get c is equal to minus 3. So therefore, using this value in equation number 1, so 1 implies, you see, y is equal to x square plus, this is y is equal to x square plus 3 over x, then minus 3 is the value of c, and this is the curve for the uh, question. This is the curve. So today we finish this video, as well as this is the end of this topic, and in the next topic we will discuss about the methods of integration, and we will discuss method of integration by substitution. So that is a very important chapter. So before going to that chapter, you should uh, memorize the formula, and also if you want to watch the previous videos, just go to the iTab and watch the videos, and then and then you should go to the next video. So thank you very much.